All right, everybody, the moment of judgment is upon us. We are ready for Case 10, certification for the apprentice level. This has two exams, 1 and 2. Let's go ahead and jump into exam 1 and see what we are faced with. So we are to determine the 7 secret genes. So in this first part of Case 10, we have to look at all of the traits, all of them, all 7 simultaneously, to determine the alleles of the female drake. And we're going to do that by breeding it with a male that we have complete control over. I am not going to give you much information on how to program the drake. We've done this several times before. You need to make a test cross, and there is a really efficient and good way to do this, but I'm hoping at this point that you can apply the reasoning that you've learned through playing this game with me to figure out what the best traits for the male will be to figure out what the female's drake's genotypes are. Now, what I am going to do is guide you into figuring out what the possible genotypes for this female drake are. So let's drag her over into our workspace and start decoding these 7 alleles. So first we want to take inventory of what the 7 traits are. So let's see, there's nose spike, that was a recent one. Let's see, wings, skin, whether it's metallic or non-metallic, forearms, hind limbs, tail. Ooh, I'm missing one. Horns. Oh, okay. Yeah, horns. Which no horns is dominant to. Okay, so maybe we ought to get a list down of what the dominant trait is as well. So I'm gonna make a little like data table here. So for each of these traits, what is dominant? Well, we just got done with the nose spike tutorials, so we should understand that the nose spike is dominant, but it's also X-linked. It's found on the X chromosome. Wings are dominant. Metallic color is dominant. Having forearms is dominant. Having hind limbs is dominant. Having a tail, having a long tail is dominant. And then kinked, those are both dominant to short tail. But long tail is most dominant. So I'm going to underline that so that we remember that that one is the most dominant of those 2 traits. And then this is a key one. That's going to be easy to mess up. No horns is a dominant trait. Okay. So then we need to figure out what the possible genotypes for this mother are. Let's go ahead and make note of what her phenotypes are as well, since those are going to inform our genotype. So if we were in class, I would have you do this as like a worksheet. I can't force you to create your own chart like this. I just think it's going to be incredibly useful for figuring out what the genotype of the mother drake is. Okay. So her phenotypes. She has a nose spike. She has wings. She's metallic. No forelimbs. No forearms. Has hind limbs. Has a kinked tail. Has no horns. So there's actually quite a bit that we're going to need to figure out about this particular female drake. So, possible genotypes for the mother here. Well, she has a nose spike, so we know that she has at least one dominant allele. We don't know what the second one is. It could be recessive, or it could also be dominant. Wings. So she has them. So we know that she has at least one dominant allele, but again, we don't know what the mother's other allele is. It could be recessive or it could be dominant as well. Has metallic skin. Again, uncertain of what her other one is. Forearms, that's one we can figure out for sure. We know she is recessive for that trait because that being a recessive trait, the only way she could possibly have that phenotype is if she has two recessive alleles. Hind limbs, that's going to be another one that is questionable. Tail, she has a kinked tail, so that means she could either be kinked or kinked short. And then no horns, which is the dominant trait. So we know that she has at least one of those. Now, let's go ahead and work together to figure out what the genotype for this female would be for her wings and her metallic skin. So the key to figuring this out is going to be to do a test cross. And the most efficient way to do this is to make the father recessive for these traits. So we make him non-metallic, non-metallic, no wings, no wings. Breed them together. So if all of them have wings, that's going to tell us something very useful. But they don't. They're 50-50. Wings, no wings. So what that means about our particular mother here is that because some of her offspring, we know that she has one dominant allele. We know that dad has no dominant alleles. So he can only pass on recessive alleles to his offspring. Because there are some without wings, and that is a recessive trait, that means that mom also had to pass on a recessive allele. So we can say with certainty now that mom's genotype for wings is wings, no wings. Let's take a look at the skin. Again, some are charcoal, some are steel, so some are metallic, some are non-metallic. We've got 60-40, but we know how that works. Works its way to 50-50. So again, if we apply the same sort of thinking here, we know that mom has at least one dominant allele because she is metallic. We know that dad, he's got no dominant alleles. In order for some of the offspring to be charcoal, that means that mom has to be heterozygous. So we can now say with certainty what her genotype is there too. So you use similar logic and use this test cross method to figure out what your female drake's genotypes are, and then come back and we will finish up with exam 2.